Imagine staring at a screen in the middle of the night, a dark room, a cup of cold coffee next to your elbow, and a single line of thermal data that refuses to behave. That's where this chapter begins. Not with a discovery, not with excitement, but with confusion, the kind that makes a scientist rub their eyes, lean closer, and whisper to no one, "Wait, that can't be right." Because on that night, as 3IAT-LAS drifted closer to the inner solar system, its temperature began to rise, then fall, then rise again, not softly, not slowly, but in clean, perfect cycles, like a heartbeat made of heat. And that's the part that shook everyone awake, the first anomaly most. Comets behave like frozen dirt. They warm up when the sun hits them, and they cool down when they drift back into darkness. It's messy, chaotic. Nothing about it is precise. But 3-1 Atlas wasn't warming randomly. It wasn't cooling randomly. It was moving through 3 exact peaks, followed by 3 exact dips, over and over, separated by the same amount of time each cycle, as if someone had put a metronome inside it, as if something deep in its rocky shell was switching on, then off, then on again. The first scientist to notice the pattern didn't believe it. She thought her software was malfunctioning, so she reset the system. Then she ran it again, same pattern. She checked the telescope feed, same pattern. She even emailed a second team, asking quietly, "Hey, are you seeing this too?" Their reply came back at 3:14 a.m. "Yeah, we see it. Heat that shouldn't exist by morning." Thermal scans were pouring in from 3 countries, all identical, all impossible. The comet was warming in a way that sunlight alone couldn't explain. The numbers didn't match radiation models. They didn't match surface melting. They didn't match anything in the physics books. If anything, if you looked at the curve long enough, the temperature rose like a machine, starting up and cooled like a machine powering down. But no one dared use the word machine out loud, not yet. Instead, scientists said safer things. Maybe there's trapped gas escaping. Maybe small fractures are opening and closing. Maybe we're reading it wrong. But every theory broke apart the moment it was spoken. Trapped gas wouldn't pulse. Fractures don't follow a schedule. And the scans were too clean, too perfect to be a mistake. Something was controlling the heat, and that thought alone made the room fall silent. The sharpening pulse around the second night. The pattern changed, not a lot, just enough, like a whisper, turning into a breath. The peaks suddenly grew, sharper, so sharp that one scientist compared it to a knife edge in the data. The dips grew steeper too, like whatever was heating the comet was now doing it with purpose. Imagine watching the heartbeat on a hospital monitor and seeing it change, become stronger, clearer. You don't need a medical degree to know. That means something is waking up. The same feeling spread through every research lab that night. A slow, cold realization that this comet wasn't acting like a comet, not even close. It was behaving like something with intent. A quiet panic by the next morning. The mood had shifted. People weren't talking over each other anymore. They weren't laughing or debating like they usually did. They were watching the heat curve, listening to the quiet beeps of the scanners, waiting for the next pulse. The air felt different, heavier. One researcher summed it up best when he whispered, "It feels like we're measuring a breath, because the cycle didn't just rise and fall. It rested between each pulse, like an inhale and an exhale, soft, steady, alive, searching for a natural explanation. Teams tried everything. They rechecked the sun's angle. They recalculated thermal albedo. They modeled subsurface ice movement. They ran simulations on dust jets, rotational heating, even hypothetical chemical reactions. Nothing fit. Every model came back wrong. Every explanation crumbled. Every answer led to the same uncomfortable truth. This object was controlling its own temperature. That meant regulation. That meant intention. That meant design. But no one wanted to be the first person to say it, because saying that out loud meant stepping into a world that no scientist is trained to enter. A world where not everything drifting through space was born in nature. The moment everything clicked around midnight on the third night, a graduate student, shaking from too much caffeine and too little sleep, noticed something strange. The timing between each heat spike matched the timing between each light pulse from earlier scans perfectly to the second. Light, heat. Two signals linked by the same heartbeat. She showed her supervisor. His face went pale. They called the rest of the team back into the lab. Minutes later, the room was packed, eyes locked on a graph glowing blue in the dark. Two rhythms, two signals, moving together like gears inside a machine. And that's when it hit everyone at once. This wasn't random. This wasn't accidental. This wasn't natural. Something inside 3i Atlas was coordinating the pulses, timing them, aligning them, driving them. But why? What was responding? What was controlling the heat? What was guiding the pulse? No one had answers. All they had was fear. A quiet, growing fear that spread through the lab like frost on a window. The final question is, dawn began to creep across the sky. The temperature curve sharpened one last time, a spike so clean and bright it looked like a single beam carved into the data. A sign, a message, a breath. Then the comet cooled again, settling back into its steady cycle. Watching, waiting. The scientists stood round the screen, silent and exhausted, knowing they had witnessed something that did not belong in the natural world. And as the curve dipped into darkness, one question hung in the air, like the end of a whispered warning. If this object can control its heat, what else can it control? And what happens when it decides to change the pattern?